Okay, on our work assignment, what we've got to remember is the work equation is this. Work is equal to the change in the energy of an object, and it's equal to the force applied times the distance that that force acted. And if it's acting at an angle to the object being moved, we can say it's equal to force times distance times cosine theta. And any one of these will work, so let's just go here. Let's try the first one here. We've got a 300 Newton tension force pulling a 24 kilogram cart a distance of 5 meters across a frictionless floor. So I'm going to use this equation here. Since I have no information suggesting that I'm at an angle, I'm not going to do that. I'm going to use the simplified version of the work equation. So how much work is done in the crate is simply the force, which is in newtons, not the kilograms. The force times the distance gives me 1,500 joules of energy transferred to the crate, or work done on the crate. Work, when we say work done on, what that really means is energy transferred to. So think of work on as energy transferred to. Now, what form of that energy takes? Since it's a frictionless floor and the object is being pulled in a horizontal direction, it's going to go faster and faster and therefore gain kinetic energy. Now, in the second problem, it says the crate in the problem above is lifted off the floor and placed on a shelf. With I'm lifting it up, if you want, you can use this equation. You can say that potential energy from gravity, gravitational potential energy, is equal to mass times gravity, times the acceleration of gravity, times the height, mgh. You could do it that way, or if really, you could just think of it this way. It's just the work equation. In this case, the force is the weight of the object, and the distance is the height that's being lifted. So what I have to do here is I have to say, well, this object is a 24 kilogram crate. So I had to say, well, how much does that weigh? 24 kilograms times the acceleration of gravity gives me 240 newtons. And those newtons are being lifted 1.2 meters in the air, so I have 240 newtons lifted 1.2 meters in the air. I end up with 288 joules worth of energy. And since I'm lifting it against gravity, what form of energy does it take? It's not going faster and faster, it's going higher and higher and higher, and it's getting gravitational potential energy. Now, take that same crate and I'm going to lift it from a height that was 1.5 meters off the floor to a height that's 2 meters off the floor. So the change in height, if you will, we could say, so the delta height is equal to 0.5 meters. So that's how much more it's going to gain. So what I then use is the weight of the object, mg, and the delta h, or the change in height. And so it acquired an additional 120 joules. So one thing to keep in mind about potential energy is it's relative to position. So it gained potential energy being lifted from this position to this position. So I don't just use the total energy of it, but the difference between these two heights. And how much work is done in the crate if it's held in place for 35 seconds? So in this one, it was lifted and then held for 35 seconds. Well, let's just think about it. I'm applying 240 newtons. It's traveling 0 meters, so I'm not that force which is being applied in an upward direction is not moving at any distance. So I'm doing 0 joules worth of work in that case. All right, let's try this. And now I've got one acting at an angle, a 37-degree angle. So rather than pulling it directly across the floor, I'm pulling it upwards. I guarantee you on the AP test you will see a problem that involves this. The good news is it's pretty easy to do. You just have to say the work done in this case is equal to the force times the distance times the cosine of the angle. So in this case, I have the force is going to be 120 newtons. The distance is 8 meters horizontally in the x direction. And so I just take the cosine of this angle, 37, multiply them all together, and you get yourself a whopping 767 joules worth of energy transferred to the object. It is going to go that much is going to gain enough kinetic energy to have 767 joules.